Coming to the important aspect of the atomic radius part, that is variation of atomic radius. Generally, atomic radius of an atom goes on varying with the variation of atomic number. As you know already, the periodic properties depends upon the atomic number. So as the atomic number of the elements goes on varying, the atomic properties also goes on varying. So here the atomic radius of an atom goes on varying with the variation of atomic number. In general, atomic radius of an atom increases as we move from top to bottom in a group. In general, the atomic radius of an atom increases as we move from top to bottom in a group. That is, descending down the group, the atomic radius will be goes on increasing. The following table indicates the values of atomic radius and their increase as the atomic number increases. So coming to the first group, that is alkali metal, especially with lithium, as its atomic number is 3, its radius is found to be 0.157 nanometers. Likewise, atomic radius of sodium is 0.191, that of potassium is 0.235, that of rubidium is 0.250, and that of cesium is found to be 0.272. As the table indicates, there is a regular increase in the atomic radius of an atom as we move from top to bottom in a group in the periodic table. So, the increase in the atomic radius while moving down a group is due to the effect of extra shell of an electron being added. Why there is a increase in the atomic radius means, as we move from top to bottom in a group, in every step, that is from one atom to another atom, there is an addition of extra shell of electron. Although the nuclear charge increases as we move down a group, its effect is small as compared to the large distance of new shell of electrons being added. For example, here the atomic number of lithium is 3. There are 3 electrons in the form of 1s2 and 1 in the form of 2s1. Means there are only 2 subcells. The half of the distance between the nucleus of lithium and the valence electron gives the radius, and it is equal to 0.157 angstrom unit. When we come to the next example, that is sodium, as its atomic number is 11, configuration is 1s2, 2s2, 2p6, and it is 3s1. It means in sodium there are 3 subcells. The distance between the nucleus of a sodium and the outermost shell electron indicates the radius of an atom. Here, as we compare the size of lithium and sodium, as we compare the size of lithium and sodium, in sodium there is an extra shell of electron is added. Hence, the size of the sodium atom increases. As the size of the sodium atom increases, the radius also increases. Likewise, when we come to the third element, that is potassium, having atomic number 19. Configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and it is 4s1. In case of potassium, again there is an addition of one extra subshell of an electron. Hence, the size of potassium is larger than size of sodium. The size of potassium is larger than size of sodium. Hence, the atomic radius of potassium is higher than that of the sodium, and it is found to be 0.235. Likewise, when we come to the element rubidium, having atomic number 37, the valency electron enters into last orbit as 5s1. Again, in rubidium, one more extra shell of electron is added. Hence, the size of rubidium is increased, as well as the radius of the rubidium also increases. Hence, the atomic radius of rubidium is found to be 0.250. So, coming to the next example, that is cesium. As the atomic number of cesium is found to be 55, its configuration is 1s2, 2s2, 2p6, likewise 6s1. Here, in case of cesium, the valency electron is entering into the 6th s subshell as s1. Here again, one more extra shell of an electron is being added. Hence, the size of the cesium increases. As the size of the cesium increases, definitely the radius of cesium also increases. Hence, its atomic radius is found to be 0.272 nanometers. So, from the table, we are going to come to know that as we move from lithium to sodium, sodium to potassium, potassium to rubidium, rubidium to cesium, there is an addition of extra shell of an electron is taking place. As the extra shell of an electron is added as we move down the group, even though there is a increase in the nuclear charge and its effect is small as compared to the large distance of new shell of electron being added. Hence, as we move from top to bottom in a group, as we move from top to bottom in a group, particularly talking with the alkali metals, from lithium to sodium, sodium to potassium, potassium to rubidium, rubidium to cesium, there is a addition of extra shell of an electron is taking place. Hence, the size of the atoms increases. As the size of atom increases, definitely there is a increase in the atomic radius of an atom. As I have told you already, as the atomic number increases, definitely there is a change in the atomic radius. And in the last discussion, we have studied that as we move from top to bottom in a group, due to the addition of extra subshell of an electron, the size of the atom increases. Even though there is a increase in the nuclear charge, its effect is negligible, as there is a addition of extra subshell of an electron, which increases the distance between the nucleus and the orbitary electron, hence the size increases. So likewise, coming to the second part of the variation of atomic radius, in general, atomic radius of an atom decreases as we move from left to right in a period in the periodic table. In general, atomic radius of an atom goes on decreasing as we move from left to right in a period in the periodic table. So the following table indicates the elements as we move in the form of a period, that is in the second period of the periodic table, their atomic number and respective atomic radius. That is, coming to the first member of the second period, lithium, its atomic radius is 1.52, beryllium, its radius is 0.111, boron, its atomic radius is 0.088, carbon 0.077, nitrogen 0.70, oxygen 0.066, fluorine 0.064. That is, as we move from lithium to fluorine, from left to right in a second period of the periodic table, here we are going to observe a constant decrease in the atomic radius. The decrease in the atomic radius across the period is due to the effect of increasing nuclear charge. The decrease in the atomic radius across the period is due to the effect of increasing nuclear charge, while the electrons are added to the same cell. Here the electrons are added into the same distance. By the way, there is a constant increase in the nuclear charge, so the increased nuclear charge attracts the orbitary electron towards the nucleus. As a result, the electrons are attracted more and more towards the nucleus, hence the size of the atoms decreases. As the size of the atoms decreases, definitely there is a decrease in the atomic radius. As nuclear charge increases, electrons are attracted to a greater extent and the size of the atom decreases. Hence, we observe a decrease in the atomic radius as we move from left to right in a period in the periodic table. Following figure indicates the increase and decrease of atomic radius as we move from top to bottom and as we move from left to right. Coming to the increase in the atomic radius as we move down the group in periodic table. For example, in case of alkali elements, starting from lithium to cesium. In case of alkali metals, starting from lithium to cesium. As there is a regular increase in the atomic number, and also there is a regular addition of extra shell of electron from lithium to sodium. Again, addition of extra shell of electron from sodium to potassium, and again there is a extra shell of an electron is added at rubidium and one more shell at the cesium. As the extra shell of electron is being added, even though the nuclear charge increases, its effect is very small as we compared with the larger size of the electrons added at the various subcells. Hence, the size of the elements increases. Similarly, the atomic radius also goes on increasing. Likewise, when we come across a period in the periodic table, as I have told you already, as we move from left to right, the atomic radius of an atom will be goes on decreasing. The decrease in the atomic radius of an atom along a period is due to the increased nuclear charge. Here, as we move from left to right in a period, in any period of the periodic table, there is a regular increase in the nuclear charge, but the electrons are being added into the same subcell. The increased nuclear charge attracts the orbitary electron more and more towards the nucleus. Here, due to the more and more attraction of the nucleus over the orbitary electrons, the electrons are pulled inward. As a result, size of the elements decreases. As the size decreases, definitely the atomic radius of an element also goes on decreasing. So here the table indicates there is a increase in the atomic radius as you move from top to bottom, and it also indicates there is a decrease in the atomic radius as we move from left to right in a period in the periodic table. So this is all about the variation of atomic radius along the period and along the group. Coming to the conclusion of the discussion on atomic radius. Atomic radius goes on increasing as the nuclear charge decreases. It means the increase in the atomic radius also depends upon the decrease in the nuclear charge on the orbitary electrons. As nuclear charge decreases over the electrons are loosely bonded. As the electrons are loosely bonded, the size of the atom will be increases, which leads to the increase in the atomic radius. On the other way, as we move from left to right in a period in the periodic table, there is a constant increase in the nuclear charge and the electrons are added into the same subcell. The increased nuclear charge pulls the orbitary electron more and more towards the nucleus. As a result, the size of the atom decreases. As the size of the atom decreases, definitely there is a decrease in the atomic radius of an atom is observed. So this is all about the today's class. And coming to my next class, in my next class I am going to give the details about one more important periodic property, that is the radii of anion and cations and their variation along the group and along the period.